1.
In this problem here, we'll call it a of x, and it's going to be equal to x, well, not a capital X, x squared plus x. And we're going to be looking at this at the point -1, 0. So we're going to want to find the derivative. Then once we find that derivative, we're going to plug in the x-coordinate -1 into the derivative. We'll go ahead and put -1 here. And find what the slope of that tangent line is at the point -1, 0. So once again, the first thing we're going to want to do is find a of x plus delta x. All right, this will be the first thing. But I think what we're going to do here before we go any further is let's look at a picture. This was the previous problem. Let's go ahead and see what x squared looks like plus x. And all right, so here's x squared plus x. And we're going to be focusing on the point -1, 0. So as you can see here, here's -1 on the x-axis, and that would be -1, 0. And it looks to me like the slope of this line, it shows it to be 0.98 here, but because I can't get it exact, I'm going to go out. I'm going to go out on this walk the plank and say that that slope is probably going to be a -1, right? Ooh, I tell you what, it's so hot today. I wouldn't mind walking the plank as long as my arms aren't tied behind my back. All right, so the first thing we want to do is find the derivative, and that means that we're going to need to have to deal with this ombre up here. And this is probably not going to be nice. But since we're learning this for the first time, or maybe just refreshing our memory, I'm selecting some polynomials that are pretty easy. Hopefully you think they're pretty easy. Okay. So we don't spend a whole lot of time, we're just looking at the mechanics here. We don't want to get caught up in the algebra. And then of course we're going to go ahead and put in the x plus delta x here. Now you notice I didn't put a parentheses around this, whereas I always put a parentheses in right here because of this minus sign. However, no need to put parentheses because this is a plus sign right here. Okay. So what we'll want to do now is just go ahead and multiply this out and then collect up all our like terms. So we're going to end up with x squared plus 2x delta x, and I wish there was a shortcut key for that. You can type it directly into the screen as long as it's not in an equation box, and it will come up. Let's see, but what do we have? We have x squared plus to put 2 delta x is there, and then of course this is going to be delta x squared. Alright, try not to make any mistakes this time. X plus our delta x. We need to collect up some like terms. We have an x here. You know what? There are no like terms. Wow. Okay, no like terms. Alright, let's go up here and go ahead and copy paste this bad boy. He's a bad boy. go up here. Go ahead and get rid of all that. I think what I'll do here is just go ahead and fill this in. Alright, so a of x was x squared plus x. Now remember, whoa, what's going on there? X squared plus x. That thing was being crazy. Remember, I've got these parentheses put in here now. Don't forget that. Alright. We're going to go ahead and do a little copy paste. Bam. You like that. Now, let's go ahead and drop these parentheses. Remember, we're distributing that negative across. Okay? So there we go. Now what we're going to do is go ahead and subtract off this function. As you can see, we have a positive x and a negative x. There's our negative x and our positive x. So those are going to subtract off. Something. Okay, what's going on here? What have I done wrong? For some reason, maybe I haven't done anything wrong. Okay, the negative x squared, and then of course we got one up at the very front. So x squared, those are going to subtract off, but I think probably what I should do is go ahead and just not make any changes to this one, and go ahead and rewrite it. How's that? Alright, so we have, right, so that negative x is going to go away, the x squared is going to go away. Okay, there's our x, got rid of that. And our positive x squared. Okay. Ooh. Looking here, we have a delta x, two delta x's, and a delta x. So since we have a delta x in the denominator, one can go into here, that'll cancel that one out. One will go into here, that'll be left with one because we have two of them. And one delta x will go into this term here, and that'll leave us with a 1. Right. So we're going to have a 2x plus our delta x, because one of them canceled out and we had to keep one because it started off with 2, delta x, and then plus 1. Now we can go through and do our direct substitution, and as you can see here, we're going to have 2x plus 0, well, that's not a 0, plus 0 plus 1. Okay, so we're doing direct substitution. 0 goes in for delta x here, as you can see, and then of course we simplify that down and we're just left with 2x plus 1. 2x plus 1. Alright, so let's go up here. So we know that the derivative is 2x plus 1, and now when we go to plug in negative 1 into this, we're going to go ahead and do that, and then plus 1, so that's going to be equal to negative 2 plus 1 is negative 1. So as you can see, the slope of the tangent line is negative 1. And just like what it looks like right here, of course I can't get it exact, but you can see I can almost get it exact, but not quite. Anyway, you can see, you get the idea right here. See, you get the idea. Okay. All right. Well, that pretty much ends the problems in this section. And so the next section here is we're going to be writing the actual, we're going to write the equation to that line. Whoa, keep on going up. That's what the next section is. So we're going to be going through the same steps, except we're going to add